Delaney said I will come a little bit later. Tell him I am taking his word that the Google Classroom has what we are doing today on it already. You press that at the end of the day, don't you?
It'll go up in a little while. All right. Today's March 7th. And for a couple days, probably a good part of this week, we're going to be solving exponential equations. And I know we kind of were looking forward to being done with logs. And directly, we are. Like, I'm not going to give you any logarithmic equations anymore unless you're, you know, in for a retake or something else. But logs are still going to be a part of what we do. But rather than the log being the equation that we try to solve, it's going to become a tool that we use to solve other types of equations. So the logarithm now becomes not just the crux of it, but rather just a part of it. So I think I want to start this just so you can kind of appreciate what we're doing with an example, so you can appreciate why we learn what we learn. Let's say I asked you for 14 raised to the x power equals 341. Currently, if I said solve this equation, if I gave you 20 minutes and said I want you to solve this equation and I want your answer accurate to 2 decimal places, what would be your strategy? Think about it. I mean, listen, let me give you a similar example so that maybe you can understand my question. If I gave you this equation, could you solve that? Right, you would look at that and say x equals 3, duh, like, why are you asking me this question, right? Or if I gave you 10 to the x power equals 1/10, you'd say, well, duh, the answer is -1. You understand those are simple, right? But the one on the left is not simple. And it begs the question of, like, how do you expect me to solve this when I have no idea what power I would have to raise 14 up to make it equal 341. So if someone popped a $50 bill down on a table and said, you've got 10 minutes, give me an answer accurate to 2 decimal places, what would you do? Say again? You can't divide by 14. The exponent says you may not. The order of operations mandates that that 14 and that x are tied together. Say again? I can't hear you. Nope. I don't know necessarily that you understand the question, maybe in the context of the desperation isn't there. Maybe if the desperation were more like, okay, you have 10 minutes collectively as a group to find the answer, or you know, the building is going to explode or something dramatic like that. If there were actual desperation, I believe at some point collectively that at least one of you would come up with the idea, we better start guessing and checking, right? So, like, for example, by the way, you're gonna need the world out of your calculators these next few days. So then the one on your phone, if you're gonna use that, that's fine, but I would encourage you to get a scientific calculator because they have log buttons on them. So the guessing and checking would begin like this. I would say, okay, 14, I'm gonna raise you to the 2nd power and I'm gonna get 196. So I know that 14 squared is 196. So I know that the answer x has to be bigger than 2. So then let's try 14 to the 3rd power. Oh my goodness gracious. So 14 squared is 196. 14 to the 3rd power is 2,744. So what could we at least now surmise about our answer? It's in between 2 and 3. And so at least if someone says, okay, I've got 9.5 minutes to go before this place blows, I can start narrowing in on it. I call it the Price is Right method. I know that's probably, bless you, that's a bit before your time, but there was a game on Price is Right where you guess high and then you guess low and then you guess high. And eventually what happens is you sandwich your way in on an answer. And so then I could try like 14 to the power of 2.5 and I'd get 733. And then I go, that's too big. 14 to the power of 2.2. And and I get 332. And now, oh, I'm getting close. And then I go 14 to the power of 2.3. And I go, ooh, 4, oh God, that's too big. And eventually you start guessing and checking. If there's real desperation in you wanting to solve this equation, could you find it? You could. It would suck, and it would take time, and it would be frustrating, and it would be insulting. The whole process would be annoying. But you could do it. But we don't want to do it that way. So again, this is not your run-of-the-mill logarithmic or exponential equation like those ones I put up a few minutes ago, where you could look at it and say, well, that's obvious, that's easy. This is different than that. And for this, we need to employ logarithms. So this, what you're about to learn in the next like 2 minutes, is at the heart and soul. It's the meat and potatoes of what we do now for probably the better share of this week. Okay? We're going to use logarithms to our advantage, and we're going to use our calculators to our advantage. Without a calculator, this will be a miserable couple of days. All right, here we go. So when someone asks you to solve an equation like this, the first thing you want to do, and you've heard this sort of theme before, and this will be more important in the next examples that we do, but the first thing you always want to do is get this by itself, and that is called the power. I know we casually sometimes refer to the x just as the power, but technically the base and the exponent together form what we call a power. So the power consists of a base and an exponent, and the first thing you want to do is get the power by itself. You've heard this before again and again and again. You've heard it with absolute value equations, absolute value inequalities. The list goes on and on and on of times when your math teacher says you have to get this thing by itself. And that's going to become your big step one for the next few days. If you already heard me say that, then you're going to have an easier time than someone who wasn't listening. Get the power by itself. After you get the power by itself, your job now is to do something, and get used to saying this out loud. We're going to log both sides. So I'm going to take the log of the left side and the log of the right side. That becomes now part of your arsenal, part of your toolbox. You know you can add 5 to both sides, you can square root both sides, you can divide both sides by -3. You can do all those things with equations. We now add into our arsenal this idea that, wait, I can just log both sides of an equation? Yes, you can, as long as the power is by itself. Go ahead. Now that brings something into play. That brings in a property that we learned a long time ago, a rather useful property. And I had said this weeks ago when we learned this, maybe a month ago, that this would become the property that you use the most. Does anyone see anything that we can do? It was known as the third property when we first learned it. Move the exponent into the front. And that is such a power move because it takes the x that's currently hiding from us. The x is like nanny boo-booing us from up in the branches. And we're like, I can't do anything about you except guess and check. But the moment I utilize property 3, the moment I take the x and I drop it down into the front, because we are aware that now that we're logged, that's legal in play. And I now have this equation that says x times the log of 14 is equal to the log of 341. At this point, it becomes a very rudimentary 6th or 7th grade kind of algebra problem. In that, if I gave you an equation like, imagine you had x times 4 equals 8. How would you solve that equation? I didn't ask for the answer. I said, how would you solve that equation? How would you solve that equation? You would divide both sides of the equation by 4. Exactly. You learned this like back in 6th grade. If I divide this side by 4 and this side by 4, I get x equals 2. We're going to employ that exact same 7th grade kind of thinking, however, on something that might look a little bit more intimidating. So our answer, even though it's not done, is okay, let me get this straight. I got to divide this side by the log of 14, and I got to divide this side by the log of 14. The log of 14 is just a number. I don't know what it is. It's 1 point something, obviously. My calculator is going to bail me out and help me. I know that the logs on the left side are going to cancel out, and I'm going to be left with x equals this. This is the part where we need to take a few minutes. I always anticipate that this will take a few minutes, and each of us with our own electronic calculating devices has to figure out how to use the log button. If you have a scientific calculator, any sort of Casio or Texas Instruments scientific calculator, and it was manufactured after like 1931, it has a log button. So for the first time, we're going to use it. We've generally avoided this because all the things we've been doing, we haven't really wanted to know or care about the value of an actual logarithm. But now we do. So on mine, there's actually a button that says log. That by default is a base 10 log, and that's what we're using here. I just logged, I log base 10 to both sides. You could log base anything, but to use your calculator, it's easier to just do log base 10. So right now, just so we can all agree that we're on the same page, practice on your calculator, hit the log button. And then it should say on your calculator screen this, log this. And it's just like it's saying, I'm waiting for you now. What do you want me to find the log of? So we're going to type in 341. And as a matter of general practice, I would encourage you to close the parenthesis. So find the right-hand parenthesis on your calculator, and your screen should now look what I have, like what I have up there. Hit enter. Let's all agree, make sure that we got 2.532754379. We all in agreement with that? Good. Now with that on your screen, just hit divided by log of 14, close those parentheses, hit enter. And again, I hope we all agree, we get 2.209835464. And our directions for the next couple days are going to be to round to the nearest hundredth. How many decimal places is the hundredths place? That's 2. Remember, the first place is called the tenths, and the second place is called the hundredths. So I would say x is, and I wouldn't actually use an equal sign here. I would use the squiggly equal sign. Do you guys remember what that represents? It's approximation. It means x is kind of equal to this. And I say to the world, by not using an equal sign, that I'm rounding a little here. And I would call it 2 point what? 2, say again? Nice rounding, 2.21. Don't be a rookie and put 2.20, because remember, if you're going to round to 2 places, you have to pay mind to the third place. He's what will determine if you round up or down. And so when all's said and done, the answer to that equation is around 2.21. Got it? There's the power of using a logarithm. He enables us to take exponents, our variables, when they hide up in the exponents and nanny boo-boo us, they enable us to say, get down here so I can attack you. We can't do that until we pull them down. All right, let's practice another one, and then I'm going to give you a couple of trickies, little shortcuts for your toolbox. So how about this one? Let's do 3 to the power of x equals 519. Everybody get an answer? I logged both sides. And since this is now our second go round, I'm going to skip a step and understand why am I logging, so I can get the x down. So I'm going to kind of 2 birds, 1 stone here. I'm going to take the x and drop it in front of a log of 3, equivalent to a log of 519. Did you guys all get 5.69? Wonderful. And again, I'll go back to the beginning of the lesson and appreciate the power of that and say, like, wow, that would have taken me quite a long time. Imagine if someone said, find it accurate to 4 decimal places. Then that guess and check method, you're talking about an hour, 2 hours. I don't even know. It takes a long time, right, to zero in on it, not with logarithms. Now, there are two specific types I'd like to show you where we can utilize a shortcut. And one of them, excuse me, that wasn't supposed to be there. Do you see anything that might just stand out to you? I mean, I know it's just another math problem, but anything about it maybe jump off? The 10. The 10 is significant because when we're working with logarithms, the number 10 is our friend. We've come to appreciate that the log of 10 is a nice thing. What is the log of 10? It is 1. And so watch what happens in a case like this. This is pretty cool. When I do my first power move and I drop the x, I get x times the log of 10 equals the log of 524. And again, what did we just say the log of 10 is? 1. And so the log of 10 becomes pointless, and this equation just solves itself by understanding that the log of 10 doesn't even need to be there. So whenever we have a base 10 in our exponential equation, we're kind of like, hey, cha-ching, thanks, dude. That's a little bit of work I don't have to do. So the answer winds up in this case just being the log of 524, which again, practicing with our calculators, I hope we all got 2.72. That 1 would round up to a 2. Can you think of one other base that would be beneficial to use a certain type of logarithm? Nope. Nope. E. We have two special types of logs that we've learned about. And I know it's been a while, right? It's not maybe fresh in our minds since we did the properties of logarithms. But a log with a base of e is called a natural log. And so I'm going to choose, and you don't have to, but I'm going to choose, because I like to do less work, I'm going to choose in a case like this, when I do my log, the log and then drop the exponent trick, I'm going to choose not to use a log base 10 like I have been. I'm going to drop the x and use a natural log. That's my choice. It's less stuff I have to type. The less I have to use my calculator, I'm always a happier man. Anyone by chance remember what the natural log of e is? It is 1. It's just as redundant as the log of 10. Log of 10 was log of like 10 to the what power equals 10. Natural log of e is saying e to what power equals e. Are you kidding me? So natural log of e, we have also come to appreciate is just 1. And so by choosing to use a different type of log here, a natural log, I have enabled myself to just type less stuff into my calculator. And so x winds up equaling the natural log. Now, somewhere very near on your calculator to the LOG button, there is, of course, a button that, again, to this point, we've avoided the LN button. So we're this time going to practice typing in the natural log. So LN, same process, it'll open the parentheses, you type in 56.4, hit enter, and we should all get 4.03. Would this have worked if we used a different kind of log? Let's find out. Let's go back and do the exact same problem again. E to the x equals 56.4. And this time, let's say that ln thing freaks me out. I don't like that. Let's just use a regular log. So let's do x log of e equals log of 56.4. Should it work? Yes. Any log will work as long as you apply it equitably to both sides of the equal sign. What am I going to type into my calculator this time to solve this one? There is no redundancy here. There are no free logs this time. Log of 10 is always just a goner. Natural log of e, always a goner. I don't see either of those. So since none of you wanted to talk to me, I'll say it for you. We're going to type in log of 56.4, close parentheses, divided by log of e. So let's try that. Using the LOG button this time, log base 10, 56.4. Make sure you close your parentheses. Divided by LOG of E. And by now you should probably know that there's an E button on your calculator someplace. Hit enter. Like, holy Toledo, look at that. It's literally the exact same answer. Right? Any logarithm will work. I just think, why not use a natural log when it's going to serve a purpose? Why not use a log base 10 when it's going to serve a purpose? You guys having a hard time finding your E buttons? A lot of you on your TI 30s, like on my TI 84, I have a button. Mine is right above the division sign. But again, a lot of you have the TI 30s. And on the TI 30, a lot of you have a button, I think, that says this. Do you see that? Do you see it? E to the X is what yours says. So when you guys type that in on a TI 30, and when it says E, when it brings up E with a little up arrow, what power of E do we want to this? 1. So I do have to type 1 and then double close. Okay. That help? Again, if you're going to make the choice to not have a scientific calculator and use your phones, we'll have to sit and visit you and I. All of your phones, if you turn them sideways, will have more functions. You know that by now, right? If you leave it upright in the, what do you call that, portrait mode, you get just the normal operations. If you go sideways, that brings in all the extra operations. So it like buffs up your calculator. Okay, good. So there's one more thing I want to show you today, and then I'll be done with this lesson, and that is that sometimes there are going to be numbers in front, and let's open up that now. So let's do 40 times 2 to the power of X equals 30. It's been 15 minutes, 20 minutes since I started talking, so let's go all the way back to the beginning. What was the very first thing I said we always have to do? Get the power by itself. The rookie mistake here, the ghetto 4th grade mistake, would be to do 40 times 2. Like we can just poo-poo the order of operations. No way. We have to identify and understand that this thing right here is untouchable. That is the exponential part. It is not to be mingling with other parts. So what do I have to do to get that yellow jelly bean thing by itself? I have to divide by 40, because that's a 40 times. We kill times with divide. So I'm going to wind up with 2 to the power of X equals 0.75. And I'm okay using a decimal in a case like this, just because it's not the kind of decimal that's going to keep me up at night. It terminates, it's short, it's easy. And now that we have the power by itself, what would we do next? Yeah, log both sides. Get those 3 sweet words. Just get used to log both sides, log both sides, log both sides, log both sides. And as you log both sides, be aware of whether or not any particular flavor of log is going to benefit us. It's not really. So I'm just going to log both sides, and I'm going to bring my X down in front. So I'm going to have X times the log of 2 equals the log of 0.75. And again, we will practice, practice, practice without a calculator. I don't know that there's many, if any, of these problems that you're going to be able to do without your calculator. Okay. Back in the old days, they used to have log tables in the back of the book. That's before my time. Even in my time, we used calculators. But they used to have these tables in the backs of books where you'd have to like go this way, like playing Battleship, and try to find the best approximation of a logarithm. Not now. Calculators do all the lifting for us. So we're going to type in log of 0.75, close parentheses, divided by log of 2, close parentheses, and we should all have negative 0.42, rounding the 1 up to a 2. Any questions there? I got negative 0.4150374993, but I rounded it off. Okay, let's try this one. Negative 3 times 10 to the power of x is equal to negative 40. After this, the problems are going to change. We'll press into the last section and then we'll be done. What would we do first? We would divide both sides by negative 3. Now, watch and pay attention to the difference between how I approached the last problem and how I approach this problem. I try to set the best example that I can for you guys. And do I hate decimals? Yeah. Sometimes I'll use them when they're not harmful. But here, if you take in your calculator and type in 40 divided by 3, what do you get? 13.3 repeating. And unfortunately, in the world that we live, some knucklehead's going to go, oh, that's about 13.3. And the entire problem from this point on is now ruined because we've taken a decimal and just wrecked it. We just wrecked it. We took a whole bunch of its digits and said, no, you're not important to me. And when you're in the meat and potatoes, like when you're in the process of solving the problem, if you wreck a decimal, you just said the rest of my work is of no importance. I'm just throwing all my accuracy down the pooper. So I choose to leave mine as 40 divided by 3. You should as well, because the decimal version here is going to suck. Now, we're going to log both sides. And we're going to have x times the log of 10 is equal to the log of 40/3. When things are ugly decimals, leave them as fractions until the very, very end. It's the only time you should do any rounding is at the very, very end. You see anything in this problem? The log of 10 can basically just be ignored, meaning algebraically the equation is now solved. The only thing left for me to figure out is what's the log of 40 divided by 3. And so again, if you hit the log button, the parenthesis is very important. That's your calculator's courteous way of saying, go ahead and do some stuff. And when you're done doing stuff, close the parentheses so I know when you're done with the log. So I'm going to do log of, and I'm going to type in 40 divided by 3, and then I'm going to close those parentheses, and I'm going to hit enter. We all should have 1.12. Well, 1.124938737, but we round. Still good? All right, final push is this. And for this first example, I wanted the initial division to come out nice rather than be burdened with multiple ideas at once. What do we do first? Divide by 12. Divide by 12, divide by 12, divide by 12, which leaves us with 8 to the power of x over 2 equals what? 2. So I thought it would be nice for our first foray into this to not have the stress of some fraction or decimal thing over there. What has always been and always will be the next step? Log both sides, log both sides, log both sides, log both sides. And so as I log, I'm aware of why I'm logging. And to do that, I pull down the x over 2, multiply it by log of 8, and set it equal to the log of 2. Obviously, there's a new kid, right? There's something 2, x over 2. Let me get this straight. It's no big deal. We're going to begin and do it exactly the same way we would have a few minutes ago. And we're going to take now and say x over 2 is equal to log of 2 divided by log of 8. Now let's just pretend for a moment that this 2, I'm going to put a red circle around him. Let's just pretend like that joker's not there. And let's more practice with our calculators. Let's all, to start with, right now, type in log of 2, close parentheses, divided by log of 8, close parentheses, and hit enter, and just let that sit on your screen. What it is inconsequential. I mean, I'll say it out loud. It's 0.33333333. Whoop-de-doo, right? But think about now, if I gave you this equation, let's go all the way back to 6th grade. If I gave you like x over 2 equals 5, how would you solve that equation? Yeah, someone, me or someone else, got paid to teach you that you just multiply both sides by 2. So think about this is the exact same problem. With that sitting on your calculator screen right now, don't do anything, just let it sit and just simply hit times 2. Of course, you would have known what that was going to be anyways. So our answer is x is approximately equal to 0.67. Because again, remember, we are rounding our answers to 2 decimal places. Yes. Yes, like I'd be fine with that. That's a pretty expert level move. But like if you wanted to do away with that kind of equal sign and say x equals 2/3, that's fine. I do think, however, in Delta Math, the answers specifically say to round to 2 decimal places. Excellent question. Like on a test, I'd be all about that action. That's cool. Yeah. All right, let's go again. 350 times e to the power of 2x is equal to 35. Step 1. Divide both sides by 350, which results in e to the power of 2x equals 35 divided by 350 is obviously 1/10, which you could put as 1/10 or you could put as 0.1. Again, decimals do not hurt my feelings when they're the good kind. Now, what kind of log would we apply here to serve a beneficial purpose? The natural log, because I see an e and I go, that's one less thing I got to do on my calculator. Sign me up for that. So I choose to say 2x times the natural log of e equals the natural log of 0.1. And I keep writing this, but of course I write it with the understanding that you, as you get better, are going to stop writing it, right? Because what doesn't need to be on the board? The natural log of e equals 1. So I realize now, sweet. I only got to do one thing to get x by itself. What is it? Divide by 2. So I'm going to, in my calculator, hit the natural log button and type in 0.1. I'm going to close my parentheses. And then I'm going to hit divided by 2. We should all have negative 1.15. Bless you. Do you guys have any questions?
What do you get?
I got negative 1.15. So I would use the squiggly equal sign. I often call it the drunken equal sign. X is kind of sort of equal to negative 1.15. Like that. I've got 3 more examples, or I can ask you, or do you feel like you get this? You okay? There are 10 of these on Delta Math due tonight at midnight. This is half of the lesson that I'd initially planned to teach. So the other half will come at you tomorrow. So it should have assigned itself 20 minutes ago or something, but it's there. And like I said, it's due before 11:59 tonight. 10 problems, that's it. Shouldn't be an issue.